Thank you.
Mostly I'm going to focus on software products because that's really where the most of my career has been. But a lot of this is now applying more broadly to generally product development across all industries. Well, first, before I really get into those details, I'm going to have a bit of a longer agenda. And so hopefully we'll get to everything. So first, I want to talk a bit about, give you some of my background. I'm going to go into some details around my career journey because I did start out in the engineering department. I did go through and get my degree in computer engineering, but I ended up really focusing on software. And I've been at several different companies, all that had slightly different characteristics that all led to where I ended up in my career today. I do want to then go into, again, this idea of the makeup of what is a product development team, what are the different roles that make up that product development team, and why it's so important for engineers to be very involved in assessing that feasibility of product and product development. And then I want to talk about why AI makes this a little bit special, why it makes it challenging, why it makes it hard, and why it's going to make it something that is going to be an opportunity for us to look into the future, but also it's going to make it hard for us to do estimation because things are constantly changing. And then I do want to walk through some real world examples, specifically of a product that we built and how that product was developed from the point of customer problem out through making sure that we're assessing feasibility. I'm also going to tease, I call this about engineers' roles in feasibility. I'm also going to talk about viability, because at the end, we can build something, but if we can't actually take it to market for a price that's going to make money, it's not worth it to build. And engineers are also going to play a role in assessing viability. And then finally, I'll give you some takeaways. So let me get started. So I'm going to start with, I'm not going to go all the way back to my birth, but I will go back to joining and moving to Blacksburg. So when I came to Blacksburg, I came with the intention of becoming a mechanical engineer. I did some work during high school with a firm that was doing some industrial lubricants, and I did some work on testing out different viscosities and temperatures, and had a profilometer that we would test the bearings and how they fix that. It was like, I'm going to go be a mechanical engineer. And I went into the general engineering program. And as I'm assuming that everyone doesn't learn Fortran anymore in undergraduate, but when I was back in 1989, we did do Fortran. And when we had our first general engineering classes where we got to do Fortran, I fell in love with programming, and two, I realized I had an aptitude for it, as everyone in the dorm would come to me and help me with other assignments. So I think I knew all three different general engineering manager Fortran assignments that they had at that time, which really made me think that when I was going to choose which major I wanted to be in, I said, I want to go into computer engineering. And that really gave me a great balance of both understanding hardware. At that time, we were working with very old microprocessors and microcontrollers, 8085s, 86s. I have to remember all the names and numbers, but it really grew an appreciation for not just the software, but really how computers worked. And I think that was critical in my career, not just in driving me into software, but it really made me a better software engineer, understanding hardware and coming from that hardware background. While I was at Virginia Tech, I actually went and did a co-op program at the Naval Research Laboratory here in Washington, D.C. And I worked for a subdivision called ENEWS, which was effectiveness of naval electronic warfare systems. And what they asked me to do, I was paired up with a physicist from Princeton University, and they said, can you please go write some missile simulations for infrared missiles? So we're really an electronic defense systems, mostly for what was RF missiles and ARM missiles, which are more electronic in nature. And we have simulations for that, but a lot of what's happening at that time, there's a lot of unrest in the Gulf. we want to actually make sure that we can effectively deploy decoys for infrared missiles. So can you go simulate some infrared missiles? And so we actually were given, had to go get that security clearance and go look at a lot of those missiles that they thought were in circulation at that time and try to implement those missiles and simulate the physics of how an infrared missile would work. We never quite got it right. It was a very cool project that we never got it quite right, because anytime the sun was in the picture, it would always hit the reflection of the sun. Somehow, whatever our math was, we never quite got it, but as long as it wasn't a sunny day, I think it did a pretty good job. When I graduated, I decided that I wanted to go into industry, and I took a job at a company called Digital Equipment Corporation. Digital Equipment Corporation was a combination of a hardware and software company that was basically making commercial servers. And it was where I was working was on a new chip that was actually very much, we were learning about it in my classes, called the Alpha chip. At that time, it was one of the fastest chips on the market that was going in the DEC Alpha new servers that they were making. Previous to that, they had a different architecture that they were relying on. And so I got to work on their True 64 operating system, which was one of the first 64-bit operating systems that was available on the market, mostly working on a lot of their system management tools to manage networks, cluster failover, what they called memory channel, which was the fast way for these clusters to be able to communicate with one another. We actually had a computer lab, and we had to pull hardware and make sure that failover would work right. And it was a really great experience, but it was very much an engineering company, and it was really had a very hardware foundation. So the culture was very much around hardware in very traditional ways in which a hardware company would work around specifications and sign-offs and specification, and it worked at the speed at that time of a hardware company. So about 6 years into that, I decided that I wanted to go try something different. And I was in the East Coast, in the Northeast. I was working at an office in New Jersey, actually, at that time. And what was really available was a lot of finance organizations. And so I decided to go try my hand and to go work in a very different environment. So I went to work with Bear Stearns. Bear Stearns went out of business as one of the first companies that went out of business when the financial crisis in 2007. I actually was not there in 2007. I was at Bloomberg. So I was a little prescient in leaving Bear Stearns. But what I did at Bear Stearns was a very different environment where we were working on building out a portfolio risk management and scenario analysis tools for mortgage-backed securities and corporate bonds, municipal bonds, treasuries, and eventually derivatives. All those different financial instruments got a lot of exposure to the finance world. I was still mostly a software and infrastructure person. I wrote all the middleware, wrote some of the tools, worked on the optimizer and some other things, but eventually it was very much a bank, and you were a cost center, and you weren't really what they valued. So I decided to go work. A number of colleagues of mine, ex-colleagues of mine from Bear Stearns, had gone to work at Bloomberg, and they had a lot of positive things to say. So I decided to go to Bloomberg and try out a different environment. And going to Bloomberg was a great experience, because I went there at a time when there was a big transition at that organization from moving in some ways to a company that was run a lot like a finance company, as some of you may know. How many of you are familiar with Bloomberg? Or I should say, how many of you aren't familiar with Bloomberg? So let me go. It's okay, because maybe, so a lot of people may, if you ask, well, what is Bloomberg? They might say, oh, it's a news company or it's a media company. Bloomberg is actually a financial software or a fintech company. And where Bloomberg started was Michael Bloomberg, the founder, was working at a company called Salomon Brothers, and he left Salomon Brothers and he got a payout, and he took part of that payout to found a new company that was called Innovative Market Systems, I think was the original name of Bloomberg. And what they wanted to do is bring transparency to the markets. And most of that was in the fixed income world, which is really bonds. Again, I'll do a little quick. There's really two ways in which companies get capital: debt or equity. And so when I say fixed income, it's usually on the debt side. There's other fixed income besides corporate debt, but we'll just focus on corporations. If they want to create capital, they either take on debt or they issue stocks or equity. It was mostly focused on fixed income or debt instruments, including government debt, treasuries, treasury bonds, and municipal bonds when local governments taking on debt for infrastructure projects or something like this. And so they wanted to make sure that nobody knew how to price. And when you had two parties, a buy side who wants to buy a bond and the sell side who's issuing that bond on behalf of that corporation, how do you know I'm getting a good price? Well, this was back in the early 1980s when there was no electronic information for this market, right? It's a very different market than, say, the equity market where there's a stock price and there's an exchange that things are trading on. This is very different. In fact, if you go and look at some history of the stock market, you'll find that it was also much more of a pen and paper kind of business as well. But what ended up happening is they ended up going out and selling a lot of these terminals. At that time, the terminal was a hardware device to provide this transparency around fixed income pricing, around these bonds to the end users. And it ended up becoming something much more across all industries. So they started out with fixed income, all those different instruments that I thought, and then kind of moved into building out equity products, mortgage products. You have things like indices and funds and other instruments that people sell in the capital markets and buy and sell, and making sure that we are providing that software to them. It went from being a hardware device with its own proprietary protocols to really being a piece of software that people run on their desktops. And that's where I came in, is that you had this software that was running on the desktops. And when I came, it was already 2006. And a lot of what was running on that desktop was ported over from the hardware controller that used to manage the hardware terminals. And most of that software looked like a terminal because it was just emulating an old terminal, which meant that you would type in, you would have a cursor, block cursor, and you would type in and hit enter, and it would send. It would kind of be like Web 1.0. It would be like the submit button, and you'd get answers back. And there was so much opportunity to improve this system. And what I was doing is I was working initially on the infrastructure pieces for both the user interface and the application building, all the parts of the application stack that people would use to build the terminal. We really revolutionized the way that our internal developers would develop applications, but also the experience for end users. And I went on to take on many leadership roles, running what we called our software infrastructure department, eventually moving on to run a group that we called our markets. Hey, we changed names a couple of times, but it's a markets, community, and AI group, which was really what is the counterpart to my role today. So 2 years ago, the CEO asked me if I wanted to move out of engineering and take over and become a product leader and to run our main business, which is our terminal product. That is the product that we sell to around 350,000 subscriptions, I think is what's published. It's more than that, but I'll give you our published number, which is 350,000, which is just south of $30,000 a year for a subscription. You can do the math. That makes it about $10 billion business. And to be able to go and take on developing the product for that business area, and now moving forward, really looking to say, where do we want to take that business? Where do we see growth? Where do we see opportunity from a business side? And part of that was really in my growth as an engineer, of going from somebody who understands the technical details of engineering into someone who is understanding engineers as a partner for business, to eventually becoming now a business leader that knows how to partner with engineers. So that is my career. Probably took up a lot of my 45 minutes, so I will try to move on to probably what you wanted to talk about, which was, but what is the engineer's role? So after this career, one of the things that's happened is you've seen the differences from back when I left university in 93, starting my career in 1994, to now. The way that the industry operates has evolved so much. And one thing that has happened, especially in the technology product space, has been the adoption of something called the product operating model. Has anyone heard of the product operating model before? Right, so what the product operating model is, it's a pivot around the way a lot of the traditional ways that product was developed, where you had business managers or marketing managers understanding what the market is, and then maybe turning it over to a team that had some agile roles, a product owner, and some of these roles that would happen, and trying to develop a project in an iterative way, but really trying to say, well, how do we tie that back to make sure that we're understanding really the value that's being developed? And so what it is it's a pivot to say, how we're going to centralize teams is really around a product, right? And we're going to motivate that team by making sure that they're driven specifically by user value and business outcomes. We're going to make sure that that team has all the different roles that you need to be successful. So I'm going to talk about a couple different makeups of teams, but you can imagine that if you're building a software product, well, you need someone that's representing the customer in the business, which is usually called a product manager. Some firms may call it a program manager, some may call it a business lead. But then you also have an engineer and an engineering team. You need a designer to help design things. You may need some data folks to be able to understand the data pieces. You may need other, depending on the kind of product, you may need other roles. You want to make sure that you have an autonomous team that has all the roles that you need to develop this product. You give them the problem that you want to solve, and you let them iterate and solve it. And you make sure that they can make those decisions in order to build the best product for the customers to solve that problem. And that's the product operating model. And that's what we really want to ground. Well, what does it mean when I have this product operating model? Why is this important? Well, it's important because you have, like I said, all the roles that you need in order to build the right product. So you'll have a product manager, really being the voice of the customer, understanding the business, understanding the market segments. You have a designer, someone who's trained in user experience, understands usability, not just from I'm going to draw a nice, pleasant UI, but I'm going to draw a functional UI, something that we know that somebody can use, understand, get their job done efficiently. We're going to make sure that we have an engineering lead, someone that can represent the technical pieces of the product and can understand the way that the product is built. I'm going to go into these roles in more details. And finally, you may have, especially in this age of AI, you're going to need data people. And that's a big shift that's happened over the years. This has become more and more important, is not only do I need to have the technical capabilities, but I need to make sure that I have good data, both from things like training and evaluation. And that's how I need a good data model so AIs can interpret it. I need to have somebody that's an expert in data, not just somebody who's a technical expert. So now the breadth of that, people that I need to build that product has just increased. And so that's the leadership team, right? They're going to make a lot of the decisions, but the whole team is going to be everybody that I need. And this is probably, if you go and if anyone has ChatGPT and you look product operating model and in the team, it might say, well, the best team size is going to be 8 people or 10 people. I'll tell you, practically, that's just not the way the world works, especially when you're talking about large-scale systems. Large-scale systems need a lot of people to execute. You still want to divide and break up your products into sub-products and make sure that you're giving people autonomy. But oftentimes, you'll have that leadership team, but you're going to have some teams of engineers. It might be 5, might be 6, might be 10, might be 2 if you're a startup. And you're going to need some data folks. It might be, again, 1 or 2, it might be 15. It really depends on the size and scale of the product. You may even need other roles, depending, again, on that product that you're building and the needs of the customer. But what are these roles and how do you want to really divide? Why is it so important? And I'm going to keep saying this, cross-functional teams are critical to building great products because every single person in that team has different responsibilities. And so the product manager is really making sure that they understand the value that we're going to bring to the customer, right? They need to understand the customer problem that you're trying to solve and how we know we solve it. What do we need to measure to make sure that we have some leading indicators that will indicate that we're solving that customer's problem, that the customer is getting value from the solution we're building. They're also responsible for viability. Viability means that we can actually build a product and sell it at a price point that's going to make money. Too often, somebody wants to take something to market that actually is not viable because the amount it's going to cost to build it is going to be too expensive to actually sell it at a price point that people are willing to pay. Now, sometimes, and I'm going to get into this a little bit later, you're going to take some bets on that either that cost is going to come down or that maybe you'll be able to drive that price up through different techniques. But in the end, the product manager is responsible for making sure that the outcomes are being delivered for the business, whether that's the sales outcomes, the value outcomes, engagement outcomes, whatever we decide is the right way to measure. That's going to be the product manager's responsibility. I'm a little bit lying in this and that I'm going to talk about why engineers are critical to the product manager really evaluating viability. Product manager cannot evaluate viability by themselves. They need engineers to be strong partners and strong participants in that evaluation. The engineers are responsible for something else. They're responsible for feasibility. Can we actually build it? Product managers often and business leaders often have great ideas of something that we can do. And oftentimes it cannot actually be built in a reasonable way with the staff, with the resources that you have, either compute resources, capital expenditures that you can make, or with just the current makeup of the team. You're asking me to build a product. We were building a product that needed one skill set. Now I have to build a product that needs a different skill sets. If you want to build this, I need to go hire 3 different people that have different skill sets. That's the engineering and the engineering leadership's responsibility to make sure that that product manager has that information in their hands when they're making that decision, and that they understand the technology, that they understand, how it can get delivered, and they understand also, can I operate it? And finally, the designer, we're not going to talk about designers very much in this talk, but designers are responsible to make sure that I have something usable, right? They're the ones who also know how to engage with the customer, understand the problem, understand where this fits into their workflow, understands where it fits into their systems, whether it's a UI product or an API. Designers are still trained to understand how the product fits and can it be usable? Is it going to be something that's going to be able to be used and adopted by the end user? So going back into that, what is the engineer responsible for? What is feasibility risk? Well, feasibility risk really has 3 characteristics. One, is it technically feasible? Does the technology exist so that I can build this product? The next is do I have the people that I can, even if it's technology, if I need 100 people to build it and I only have 5, well, it's not feasible. I can't practically do it, even if the technology doesn't limit it. Or I can do it, but I need more compute. I need a new data center. I need more racks, or I need other things that we don't have. So so part of that middle is, well, can we build it with the resources that we have? Not is it technically possible, but can we build it with the resources? And then finally, once I built it, how do I operate it? How am I going to deal with scalability? How am I going to deal with issues that happen in the field? Can I go, and if there's a problem, and let's say we are building something that's a hardware system and not a software system, after I deploy that and sell it, what's going to happen when it breaks? Do we have a path to be able to fix and repair and send back? So part of the operation, part of that feasibility is also saying, am I going to be able to handle both the scale and the support moving forward? Now, why is this so important? And why did I break this into this AI talk? Well, one, AI is not just generative AI. AI has been happening for a long time. I actually took an AI course when I was at university, and that was 30-something years ago. So AI is not something that's new. In fact, I think up there, I'm like, oh, that is actually even before I was born. I had a class in Lisp. I think you do. Does everyone even know what Lisp is? It's a programming language that used an NLP. It was a very good fit for a lot of this NLP related things back when it was non-statistical. And we had to build an ELIZA was one of the first AI systems that pretended it was a therapist, and you can chat with it like it was a therapist, but it was not built on any statistical models. It was a much more simple model at that time. But you can see what's happened is the technology around natural language processing, which is a big part of the way that we want humans to interact with computers, has evolved over time, right? We've gone from rules-based systems to more statistical systems. We've understand how to understand grammars better, how to map those grammars, and be able to do named entity recognition, and named entity. When you map the entities to the items, NED, I guess, named entity detection and named entity recognition. We've had a lot of different ways in which we could process language that has changed over time. All of this culminating in that last bubble, which is 2020, which is where we see this explosion based on generative AI, large language models, but even some of the predecessors before that, transformers. And when you take a look now, going from that to the timeline of LLMs, the things that have happened since 2017 until now, and now is actually a snapshot from a few months ago, has just been tremendous. The amount of improvements that happened from the first initial transformer papers that were written going forward has really changed the capabilities of what these systems can do, to where when you're thinking about the feasibility of building a product, the landscape changes every day. It went from something where I had transformers, and yes, I can do some clustering. Yes, I can do some generative. I can do some generative text, and yes, I can do some simple things. Yes, there's a lot of hallucinations, and yeah, there's some problems, and no, the systems aren't really reasoning. They're not reasoning, so we can't really rely them on reasoning. Yeah, no, they can't do math, and they can't do that. And as we move forward, we'll see that these problems are getting solved at a pace that we haven't seen since the internet, and a lot of the internet booms and things that happened with it, the internet being this new technology that we were building systems and software and solutions on top of. And so this is really going to make it difficult for you as engineers to really understand what's possible, because what's possible today, or which I should say, what's impossible today might be possible 3 days from now. And that means that you're going to have to start thinking and understanding where things are going in a very deep way, looking at papers that are being published, understanding what's happening and where the research is going, and making some assumptions and some just using your intuition as someone who's been doing this for a long time, really trying to predict where it's going. Where do you think the technology is going to go based on the timeframes of the product and the product delivery that you need to make? And so what I wanted to skip here is really to talk about, well, how did this impact me? Why did I do this talk? And let me see if I can move this. Oops, sorry. Does that still work? Okay. So as I said, part of this product operating model is that you want to really give a team problem. Right? You want to say, please go solve this problem for me, because I think if we solve this problem, we can make money as a business. And so one of the problems that we have in the finance industry is, if you think about the process of the investment process, a big part of that investment process is in doing research. And there's a couple of different ways that happens with research, but on the buy side are the people who are mostly buying securities, institutional investment that are buying securities, asset managers, which are managing mutual funds, hedge funds, they might sovereign wealth funds. There's a bunch of people that are buying those securities and managing portfolios. You can have it on the wealth management side. They need to make some decisions. And typically the way they do it is that they have a bunch of people that are research analysts. And those research analysts have to understand what are the stocks. We'll talk about equity research. If I want to say, what are the companies that we want to invest in? Based on a lot of different characteristics. Some of that may be macro level characteristics. What industries do we think are going to perform? If you think you're out right now with data center needs and power needs coming from AI, it's not just AI companies you want to invest in. You want to invest in companies that are going to help data centers get built. And so there may be areas and opportunities for investment, but you really want to make sure that you also understand the details of those specific companies. And so what happens is a buy-side analyst is going to say, I'm going to have a thesis that I think we should invest in X company, or my portfolio manager should go headlong in some industry. And so the way that they do that is they have to review lots and lots and lots of documents. Has anyone ever looked at an earnings call transcript? So if you know that earnings call transcript, is it a short document? It's not a short document. An earnings call transcript is a very long document. And you can imagine that if I want to look at a whole bunch of companies, I have to read through a lot of these earnings call transcripts. But an earnings call transcript is not going to be the only documents that I want to read. There's going to be other independent research that's going to be built. And if you're on the buy side, you also have, you're usually you're a client of the sell side, which you sometimes call brokers. And the sell side also produces research, and they produce research. And so the buy side has to cover a lot of names and a lot of it because they're investing in a lot of different ways. The sell side will have very specific research that goes very deep on a company, and they share that research and price targets and other things. And they'll share that research with their clients, the buy side. And so the buy side wants to look at, oh, what is all this the sell side saying? So they have to look through all these documents, and they spend a lot of time, especially during earnings season, where instead of trying to come up with a thesis, they are reading documents and finding documents. What documents are important? What should I be reading? Yes, earnings calls are very obvious, but there's probably other documents. There's news. There's things that I need to understand so that I can actually make an intelligent investment decision for my portfolio manager. And so that's the problem we want to solve. Can we save that buy-side analyst some time so that they can focus on the alpha generation part of their business and not just the reading documents part of their business, of their job? And how are we going to know that we're successful is we're going to look at the outcomes, right? We're going to manage those outcomes. And what we want to do is we want to acquire new users, right? We want to say, we're going to sell our product to more users, or we're going to, at least if somebody is buying, what I should have gone back, I'm sorry, I'm going to take a little bit of a detour because I probably should have said it in the beginning. If you're not familiar with the Bloomberg Terminal, a little bit about our business model. We sell a singular price subscription. I kind of mentioned it's a little south of $30,000 a year for a subscription to the Bloomberg Terminal. It gives you access to everything that we have for our product, which includes all asset classes, all structured data, all unstructured data, all analytics, all the screens and pages that we have in order for you to be able to go cross-market. Because what we know about our users is that oftentimes they don't know the data that they want. So if you're, say you're in the energy sector, you're an equity analyst that's covering energy sector, well, you probably are also care about commodities. You want to understand what's happening in the oil markets. You want to understand what's happening I guess, oil markets, the natural gas markets, and you want to understand research that's happening there. You also may want to look at macroeconomics. So instead of making somebody say, oh, I just got the equity package and now I'm going to have to go buy this other package, one price product. This has been the business model since the day that Bloomberg started. It's a singular subscription fee, goes up every 2 years based on inflation. That's the price. The price is not that. The price that I just mentioned is the price if you calculated inflation adjusted from the price that it was sold at in 1986. It's the same price, and I'm not sure 1986 is exactly the precise date that the price was locked in, but somewhere around that time, been the same business model. So that's one of the things that, and so going back to this problem, what we want to do is we want to make sure that users of the terminal get the most value out of that terminal. So we may have somebody who's a buy-side analyst that is using the terminal for maybe pricing, or maybe using it to get up-to-date news and some other features of looking at, I don't know, the fundamental reporting that comes out of those earnings calls, but not using it to do this research, this investment research validation. And so one of the things we want to do is not just acquire new users, but we want adoption from our existing users of using new features as part of this investment process. So product team says this is the problem, working with design teams, going to visit customers. And yes, we bring engineers to customers, engineers just as much as designers, just as much as product people, go and visit customers, go talk to customers. And what happened is we said, okay, well, what do they need? Well, they need the ability to go and go either find documents. Sometimes they just want to say, hey, can you get me the last 5 quarters of Apple's earnings calls? And we should understand that this is a navigational query. Go get those documents, bring them back to them so they can navigate. Or if they say something more interesting, I don't know, how is Apple expanding operations in India? We can now go and look at the vast amount of documents that we have, both company documents, research documents, news stories, and bring back and synthesize an insight or intelligence for them. And so you go to the engineers and say, this is what I want. Can we do this? Because this is ideal, right? This way they don't have to read the documents. We'll read them for them and we'll give them the insight. We hear these LLMs are powerful. What can we do? Well, engineers have to make sure that they understand what it is that they're doing when they go to assess this feasibility. So the first thing you need to make sure that you understand what the hell they're saying, right? It needs to be, what are you actually asking me to do? And so part of that is really going and making sure that you're talking to the product manager, the business manager, the designers, also the customers. I cannot emphasize enough how much value engineers say that they get when they actually go talk to a customer to say, well, what is it that you need? That will get that value and be able to bring that back and really understand, can we build something that is going to solve this problem for the user? The other is you really need to make sure that you understand, well, what is that requirement? How fast does this need to be? What if this takes an hour? Maybe I can do it, but it's going to take an hour. Is that going to be enough? Right. So making sure that, that an engineer is asking those clarifying questions around, well, what is the requirement? What is it that is going to satisfy that user? Again, getting that from the product manager, the designer, and the customers themselves is going to be really important. Making sure that once you decide that you understand those things and you're going through that design, that you're saying, well, what are the things that I don't know? And some of that may be, well, we actually haven't built a product on top of LLMs before, so we're going to have to learn. So that's an unknown. We're going to have to discover, how do I use LLMs? How do I go? Some of it may be just infrastructural. Do I actually know how to connect to those things? Do I need to run on-prem? Can I run it off-prem? How am I going to train? Do I actually have a set of people that are going to be actually help me train and validate that I have good performance? Are the customers willing to do that? So a lot of these questions are going to have to get asked as you go. And eventually you're going to have to get to the point where you go on a deep dive, you build an architecture, you validate it, you build a prototype, you create some artifacts to give you more confidence that this is something that you can build. Oftentimes that's done in terms of, is it on here that we talk about a spike? Yeah, I think, does everyone know what a spike is? I realize there's some terminology that may not be used as much academically. A spike, if people are using agile development, which I think people use the terms, not necessarily all the what do you call rituals and all the rest of it, but a spike is usually just means we're not actually going to produce anything of value other than research. We're going to do some research for the next weeks. So 2 weeks, 3 weeks, 4 weeks, we're going to do research, and people call that a spike. So you're going to spike to try to get information so that you can make a future decision. And then once you do that, then you have to say, okay, well, can I operate it? How much is it going to cost? What does it look like? Do I have good observability, right? Part of being able to operate something is, can I observe if it's performing okay? Can I go remediate when there is an issue? And eventually you want to put that back in some kind of report, a matrix of some kind, so we can say, yes, we think that this is feasible, or this is where we think it's feasible, but here's still a couple of unknowns, but let's go for it. And so the reason why this is really important with AI, again, is that things change so much. So when we were developing this product that I'll show you a quick video in a second. The first attempt that we did at it was very much where the industry was back, I guess, almost 2 years ago. What did we build? And I'm not sure if you can see everything on here, but this is basically, we have a search system, and what are we injecting into the search system? Well, it used to be an index-based search system where we had some amount of taking documents, splitting them up paragraphs, indexing it the traditional way. But now what do we want to do? We want to add some amount of embeddings, because we want to also be able to vectorize it, so we can have we can do semantic search on top of it. We want to make sure that eventually then we can go and we can summarize, right? This is a typical RAG system, right? A retrieval augmented generation system. And what happened is we went out to a couple of customers and we said, how is this? Here's our system. We went out to it. We took the query, did some amount of query interpretation, and eventually passed it to a RAG system. We returned some documents and said, summarize the top ranked documents. And what happened is we got very lukewarm response. It's like, this is good and it's helpful, but it's really not going to save me that much time, because it's not going that much deeper than most of the stuff that I already knew, because what you found was not the interesting stuff. You found the stuff that your highly ranked stuff is stuff that we already knew. And so it's not really giving us anything novel. what it's doing is stuff that I already know. So I'm really going to have to go back and read all these documents. And so, yeah, I'll probably use it, but yeah, it's not going to be, it's going to not be life-changing for me. So in comes agentic AI. So what does agentic AI allow us to do? Well, it allows us to take that RAG system, but now instead create a way for us to have this kind of agentic loop on top of a set of RAGs. It's not a singular RAG, but it's a set of RAGs for different collections. And now the AI can go as deep as it thinks it needs to go to find novel responses. But the other requirement as we were doing this was one of the sets of documents that we have are come from that brokers, which is that relationship between the buy side and the sell side. And so the sell side actually uses our system and they can entitle the buy side to get their research. But what they said is they said, hey, this AI stuff is pretty cool, but we don't want you to disintermediate us. And we also don't want you to make it ambiguous about whether we said something or one of our peers said something. So we do not want our research to get aggregated with somebody else's research. So if you're going to show our research, you need to make sure that it's only what I said and that it's attributed to me and that everyone knows it. And by the way, this is kind of a combination of not just the broker saying, we also think it's a good idea because by giving us that attribution, part of our product is that we're a community product. And so if somebody sees those results, and I think we'll see it in the video, is that the person on the buy side can actually use our tools to start a chat with the person on the sell side and say, hey, really, what did you mean by this? I thought this was some interesting thing. You actually had a contrarian opinion to everyone else. Why did you come up with this opinion? And so it allows us to escalate that insights and search results into a conversation with somebody on the other side. But what this allowed us to do is that because the technology evolved, the engineers can come back and say, well, you know what you were asking for wasn't feasible with our old architecture. And maybe it's not even feasible with the old set of resources. But if you can give us some resources so we can actually build out an agentic system, so we can actually go out and bring back those documents. If you're okay with changing your latency requirements from 30 seconds to 2 minutes, we can actually do what's being asked. We can go read hundreds of documents. We can actually bring those insights, those novel pieces of information to the customers, to those buy-side analysts, so they can make good investment decisions. And so that's all great. We know that it's feasible. We know that we can do it. But should I, right? So now this is where it's a product person's decision to say, well, is it really viable for me to go build this agentic system? And so what do we need to do is we actually need a lot of information from engineers to make that decision, right? We need to know, well, how much is this going to cost? And so now this is where engineers and product and business teams need to really partner very closely, because this is going to be about, well, how many users do we think we're going to have? Well, what does success look like? How many queries do we think they're going to run? Well, how many documents do you think you're going to have to go? Oh, now I have the sell side requirement where I'm going to have to summarize every sell side document separately and then probably re-rank them. And now I'm going to have how many calls to LMs? How many tokens am I going to need? Which is the best provider? So who's giving us the best performance? Should we go to Gemini or OpenAI, or should we use Anthropic? And so all these decisions now have to come together between this conversation between the business manager or product manager and the engineering team. And as you start to understand these questions, then we can say, yes, what do we think? Well, we think that we can take this product to market. It's going to cost us X amount of dollars per user. We think that the price is going to come down because we can see that the price of inference, as opposed to training price is going up, inference price is going down. Is that trend going to continue? Nobody knows. Hopefully it continues. We're all going to estimate that it's going to continue. We're going to hope that it continues, but it's quite possible the models get too big or they get small. Can I distill the models? Do we have new techniques we can use? And so a lot of this is going to be predicated on a future state that is unknown to us, where we're going to have to make educated guesses as partners between engineers and product teams that we're going to build a viable and feasible product for customers. So I don't know if everyone's going to be able to hear this. Let me. This is one of our promotions.
Did you know you can use AI to extract insights from millions of documents on the Bloomberg Terminal simply by asking questions? Here's how. Run DSX Go and launch the new document search and analysis then type what you want to know in everyday language. For example, what is Ford's plan for reaching profitability on EVs by 2026? DSX searches within our vast library of over 400 million high-quality documents, from company transcripts to sell-side research and exclusive Bloomberg content, to find you answers. An AI-generated summary enables you to understand the key themes fast. Transparent attribution enables you to view each insight in its original context. And you can connect directly to the analysts behind the research by starting an IB chat. Built for financial professionals, DSX reimagines your research workflow for the age of AI. Want more Bloomberg Pro tips like this? Follow us to see more.
And so just finally, before a little bit over time, but finally, what I wanted to say is that in the age of AI, or the age of any dramatic technology change where technology is changing very quickly, assessing feasibility, assessing viability is always going to come with some risks. There's always going to be inherent risks. But engineers are in the best position to help make great business decisions. And that means that you're going to have to understand the technology environment. You're going to have to make sure that you know those pieces, and that when you're making those decisions, that you understand those known unknowns and trying to mitigate against them. That you're really looking at the technology in a way that you're bringing your expertise to solve business problems in the best way possible with the most information that we can use, so that we can make sure that we get products to market that customers love, enjoy, and in the end, make a business profitable. So thank you, and I will now take any questions.
How did you make the jump from your first job to the finance industry, and what advice do you have for people trying to do that in the current job market?
Yeah, so at the time, some of it is unfortunately, it was a long time ago. It was 1999 when I made that change. And at that time, there was less big tech in New York, and I was living in the New York metropolitan area. And so it was very common for people. I should say big tech was different. We had Lucent and Concurrent and Digital, which became Compaq. Sorry, no, that's a lie. Compaq acquired Digital. And at that time, that was a little bit of a mecca. That was mostly in New Jersey, in a couple of different areas of New Jersey. And so a lot of the folks from the tech industry, the more pure tech industry, would move into the finance and the banks. And the banks were one of the people that were hiring a lot of different engineers, banks, and other people in finance, because New York has a lot of finance firms. And so at that time, I wanted to go work in New York City. I wanted to work in Manhattan. And so I just started applying. And I applied to quite a few different companies at that time. I don't even remember all of them. I just remember that I had a job offer from Nomura, and I had a job offer from Bear Stearns, and I decided to take the job at Bear Stearns. Part of it was that the hiring manager also came from one of the tech companies that was in New Jersey, one that was building CAD software named Mentor Graphics, and he was also a professor at Columbia University. And so one of it was I was attracted to the role, not just because it was finance, but because I thought I would have a great mentor. And he became one of my great mentors. He's actually one of the reasons he actually moved to Bloomberg. He's one of the people that moved to Bloomberg in probably 2001. So I joined Bear Stearns in 99. I think he moved in 2001, 2002 to Bloomberg. I moved to Bloomberg in 2006. But he was in that short period of time. And even at Bear Stearns, he was my manager for 4 months. I think I learned more in that 4 months around software engineering, software design, architecture than I probably have in most of my career. I learned a lot of other things since then, but the transition was really about going and just applying to a lot of places, being open to different kinds of roles and jobs. But everyone values coming in with some knowledge. So I would recommend if you ever want to shift industries, that, engineering, going in and saying, yeah, I know a lot about engineering is great, but coming with that you've done some legwork and some homework around the firm that you're going to, around the industry that you're in. So you're bringing, not that you know it and that you're an expert, but you're bringing this sense that you're curious, that you have the curiosity that you need to succeed in that new industry or in that field. Because again, engineering is always the merger of a business with delivery and execution. And so making sure that you understand a bit about that industry that you're trying to go into is really going to be important, and show to that hiring manager that you're interested and that you're curious.
Any other question?
You said a lot of great things, and I really enjoyed the conversation. One of my questions to you was, as you progress throughout your career journey, what would you say are those key takeaways from each step and each step of the way to get to where you are now? What are those key takeaways that kind of help you that jump to where you are now?
I think the biggest thing was always being open to opportunity and never closing doors because you didn't think they were going to be what you wanted. I've done a lot of things that are uncomfortable, including the role that I moved into. I'm not someone who I'm not someone who really had a business background, or that wants to go and feels comfortable going talking to a bunch of clients and going on big business trips. It's not something that was like exciting. It was exciting, but not something that I felt that I was necessarily going to be comfortable doing. And so it's okay to be, and you have to recognize whenever you make a shift in your career, you're going to be uncomfortable, and people are going, especially I'll tell you, when you're in a more senior role and you shift to another senior role, even if it's something that you're still learning and you still don't know, people are going to look to you that you're the expert and you know everything. And so you have to be comfortable being uncomfortable, almost in any step, both being from a technology point of view. Say if you're going to move from one part of technology to a different part of technology, even if it's within software, you're going to move from one part of the stack to another, or from one domain to another area. That discomfort that you're going to get, you get over it, and you have to recognize that you're going to get over it. I mean, you wouldn't be here if you didn't have the capacity to learn, and the capacity to adapt, and the capacity to meet different challenges. And so I think making sure that you're willing to be uncomfortable, looking at opportunities as both lateral opportunities, geographic opportunities as a place that you're going to be able to leverage and learn. And nothing is you can always change things, right? You can always change jobs. You can always move. A lot of bigger companies, you can always move within that company if something doesn't work out. But giving things a try and trying to see what is the thing that makes you happy and excited. You always want to be happy and excited, right? I would not recommend going and doing something that you think is going to make you miserable. Uncomfortable and miserable are different. It's okay to be uncomfortable, as long as you understand that you'll get past it. And if you don't, you can change. You can always go and change your career. You can always pivot. And so it's always a good idea to just keep open and make sure that you're looking for those open doors.
So that was terrific. Everything that you were talking about with teams, I wish I could just bottle it, put it into a syringe and inject it into each of the students, but then again, can't do that, it turns out. But I am very curious if you could think about, it's along the lines of the question you just got answered. Is there anything about your Virginia Tech education that you look back on that just kind of served you well through those transitions? So you talked about you need some resilience and some ability to handle stepping into an uncomfortable position initially, maybe, and just kind of fortitude to get through that. Is that something that you can?
Yeah, I mean, I'll give you both a very tactical and very narrow. I'll give you a very narrow example, and then I'll also give some more bigger examples. And I think very narrow. The technical writing course that they had for engineers was probably one of the best things that helped me with my career, partially because they made you public speak. And you had to go and not just be able to write a good technical document, but you had to go present a technical topic to an audience of your peers, which is probably the hardest audience to present to. And it just really put me in a position. And at that time, I was terrified of public speaking. And I mean, I was probably even terrified up until 15 or 16 years ago. But it made you say that, okay, I can do this. I can do something that's comfortable. And I'll always remember that class as being as something that really put me outside of my comfort zone. But I do think that overall, just the overall curriculum, the experience, the projects, the interaction with the other students, it's really just the aggregate of the experience made me feel very comfortable going to interviews. I felt very much like I not only had a theoretical academic education, but I also had a very practical education, both with a lot of the programming and other things that we had to do. A lot of it was in assembly. I don't know if I bet you, nobody programs in assembly anymore. I did a lot of assembly, all right. But also, and a lot of programming, but also coming up with the projects. I remember the last couple of projects that we had in digital design, just really made you not just have to understand the technical, but you had to be creative and say, well, what is the project that I want to do where I'm going to actually do something that makes sense. I think at that time I did like a fire alarm system that also was a burglary alarm system, and had to have sensors and some other things that we had to produce. But it was, I mean, it was definitely, I think overall, I think just the practical, meaning the theoretical, just generally prepared me to go in to it. I also I think some of the going into cooperative education and being able to partner with very early in my undergrad with a real job doing real industry things was also very I think important for me in getting that experience. And then you bring that back, and then when you're doing your coursework, you kind of now can see something that's much more practical, right? It's no longer theoretical. There's a practical aspect to it.
How do you handle situations when there are delays or disruptions to the schedule and deadlines promised to the customer because of internal reasons such as engineering or manufacturing issues or conflicts?
You handle it very carefully. No, it's inevitable. We always, it's always a joke, and it's that engineers can't estimate, and even if you double it, you're still going to be off by at least 2. But it's not completely true. It's a lot very unfair, I think. But it happens, right? What's going to happen is that it's going to be unfair. And what you try to do is you try to make sure that for the most part, well, one, you want to reduce the amount of times that happens. So a lot of things you want to say, I'm going to be iterative, I'm solving problems, things are going to be incremental, and we're not going to make those customer commitments, right? The product is just going to get better incrementally. We're going to solve problems. And when we're close to solving them, when we're done with those unknowns and they're all knowns, then we can go to the customer. It's only in certain times where you're trying to get a deal done, or the customer's betting on you, on the future you, not the current you, to go sign a contract, where you really want to make sure that you're going to meet those deadlines. And sometimes it doesn't happen. It just, in the end, things come up, other priorities for those teams may get in the way. There may be technical unknowns that they just got to that made projects takes longer. And really that is where product managers and sales and support teams come to play. We are very good at going to those customers and selling them still on the dream, being transparent. This is what happened. This is what we're going through. Some of it may not even be anything to do with the engineering team. It may be regulatory or controls, or we're trying to get something in place. We want to make sure our legal has signed off. And there's a lot of reasons why things get delayed. And when you're having those interactions with customers, customers appreciate transparency. And now so going to them and making sure that you're keeping them up to date, especially if there's a commitment that you've made as partners in something. Or you want to make sure that you make some trade-offs to say, we might not have given you everything, but here's what we're going to do now, but still say that now we're going to recommit to a new date. and really trying to make sure that when you're making those commitments, that's where your priorities are. So one of the things that is also on product teams is you shouldn't be making commitments on things that aren't our top priorities. Right? We should only be making commitments on what our top priorities are, not what is maybe good for this one customer, right? We don't want to be the product operating model. One thing that you didn't see there is it's not a sales-led model, right? It's a product-led model. It's about customers and doing things for customers and making sure that you're prioritizing product at scale for all of the customers, not for an individual sale. So for the most part, you want to try to avoid that. But when it's unavoidable, the product team's job, part of the product team's job is really to shield and be good partners for engineers, be understanding of those unknowns. That's one of the reasons why my moving from an engineering role into a business and product role is very positive for the way that we want to build products, is that I can have that empathy with engineering teams and some of the things that may happen. I also, even though I was never in legal, I also have empathy for our legal team. But in the end, it's really about managing that message to the customer, making sure that you have enough of that good relationship when you go to make those commitments. Now, there's other things that happen where we just have a date. You have a go-to-market date, and I have a go-to-market date. We can't talk about it, but we have one that's January. We have a general audience release that we're trying to go out with something that is not ready. And the decisions that we'll make is what we want to say is we're going to go out. It might not be with what we hope to go out with, but we're going to go out with something. So making sure that you're getting that right priority decisions in place, so that when you do go to market, you're going out with something that adds enough value that it's not going to be embarrassing, and that you're good partners with the rest of the team that's involved in building and bringing that to market.
Thank you. Thank you for the informative and inspiring time. Thank you very much. I think we are doing great with time. Any final question?
You talked briefly, you had an anecdote about you rolled out a kind of a feature, it was a rag, and you got kind of a lukewarm, maybe underwhelming response from customers. And then it sounds like you made the decision to, rather than that, you could have decided to say, oh, we're going to dump this, we're going to go a completely different direction. It sounds like you made the decision to refine it, go further. Can you walk us through a little bit how you navigated that decision? It sounded very interesting because, like, I'm sure the customer didn't suggest, oh, we should do an agentic, loop in here.
Yeah.
How did you navigate that decision?
Yeah, I mean, it's difficult, and it's always difficult to make the decisions, because there was a lot of pressure, and I'll be honest, this is a good thing, because there's a lot of pressure from even my management team, which is the CEO and the founders, to release something. And we just said it's not ready. And at that time, and just to be fair, at that time we did have other streams. We always have streams of people that are doing more forward-looking research. We kind of had an agentic system that we were playing around with already, because we're kind of always have like what's out there and what's coming, both from a technology point of view and a product point of view. So we just made the decision that we're not going to incrementally go out with something, and we're just going to pause this, not go out to too many more users. We just had a small beta or alpha set of users that were turned on, and we're just going to pause it there. One, we'll look at adoption, and we'll say, how much churn are we getting? Are we getting people coming back? And if we don't see any indication that this is really adding value, let's just pause it. Let's now start going out to some of the early good, the friendly feedback customers with this new agentic thing. Say, is this better? Is this going to satisfy it even when it's early? Is this directionally what you want to look at, or what you're thinking, and getting that feedback from them, made it very clear that, yeah, this is the way to go. And I'll be honest, it was we want to give our teams autonomy, so it was really the on the ground product manager who runs that are kind of our research agent, and our research system wasn't the research agent at the time, but it's now the research agent. make the decision that, we're better off waiting, and they had to manage those expectations. This is one of the cases where we had to manage those expectations. There were people that were betting on, we're gonna turn this on for everybody. We're gonna start integrating internal research for people that use our research management solutions to publish their research onto our system. All of that was a little bit delayed because we wanted to make that shift. And it's just a decision that, one, it wasn't made in isolation. Is it completely an autonomous decision that the product team is able to make? No, I mean, this is AI is a big, most strategic enough thing that most companies are doing, that it does get escalated to more senior powers. But usually, again, as long as people are transparent about why we're doing it, it makes sense, it's justifiable. We'll go in that direction. And it wasn't just, we're going to completely shift. We kind of had known that this was the direction, or looking at conversational interfaces and other things that are being explored. So we had a lot of stuff in the background that we could utilize.
Okay, thank you. So that concludes.
All right.
Thank you very much. Thank you.
All right, thank you.